This is a chi-squared independence test example, another two-way test. Once again, the name of the test, the type of the test differs between homogeneity and independence, all because of how the people or items are sampled. So in independence, we have one big sample. For example, like if I'm interested in schools that students go to and the color car they drive. If I go to Lubbock High and ask a bunch of students what color car they have, and then I go to Monterey, ask them, then I go to Coronado, ask them, and so on, go through all the high schools, that would be a homogeneity test because I'm doing independent samples at each school. If I go to the mall, if I go to Starbucks, and I just walk up to teenagers, I'm going to have to ask them two questions. I'm going to ask them, what school do you go to, and what color car do you drive? So that becomes an independence test because it's one big mixed up sample. All right, expected values still need to be greater than 5. All the math is identical to the homogeneity test. Let's run this test. Oh, actually, before we move forward, just like with homogeneity, the null was same. With this one, the null is independent. Those words go together in our null hypothesis. And then for HA, you're testing for an association. Okay, now let's do it. This one, we're trying to determine if heart disease and anger, level of anger, are associated. So notice at the very, very top, we have one giant sample of people with normal blood pressure. So when you see that one sample taken, that's an indicator. Where could we write this? That we are looking at chi-squared independence. Another hint, although it's not always correct, is they use the word associated down here. I've seen some questions where they mix that word up in their question. So you want to go off of how the sample was taken. But it's a hint. It's a way to get to the right answer. We're looking at people with normal blood pressure. So let's write our hypothesis. Heart disease. Is independent. Notice that's the name of the test, so that's the word I use in my null, of level of anger for people with normal blood pressure. And then HA is the opposite. They are associated. They didn't give us alpha, but let's just let alpha be 0.5 and move on to the plan step. We have one random sample, and just like with homogeneity, I'm going to write expected values over here and make a big empty matrix to remind myself to go look for them in the calculator. Let's see, we have a 2 by 3, so I need maybe that much room. They're probably all greater than 5, so I'm going to go ahead and write that so I have room for it. And let's move on. Let's go to the do step. We are doing a chi-squared independence test. Our formula. Oops. And then we need the calculator. Be careful when you type. We do not want these totals. Sometimes I put a line through those totals so I don't accidentally type them. We need those 6 numbers, a 2 by 3. So let's do that on the calculator. Maybe try and beat me to it. Run the test without me. So on the calculator, we need a matrix. Press the button right next to the 9. And then this one that's already highlighted lets us customize the matrix. We're doing a 2 by 3. And type in your numbers. And then we want to store this as a variable. So control var, press A, or whatever variable you want, and you're good to go. Go to menu, run the test. We're doing a two-way test. I called it matrix A. And there are our results. It's a small p-value, looks like it was significant. Evidence suggests an association. When you press var, you want exp matrix, and you write in your expected values. So let's wrap this one up. Chi-squared was 1607. 68 with 2 degrees of freedom. The p-value, that looks bad. Let me rewrite that. Some of y'all might have gotten it in scientific notation. You know, if we have that many zeros, you're safe to just write approximately 0. It's less than alpha. Let's conclude. We reject HO. Evidence suggests an association between heart disease and level of anger. I have room to write it for people with normal blood pressure. Oh, barely had room. Remember, go back and find your expected values. I want to show you by hand how to do it if you're interested. Remember, it's the marginal totals divided by the grand total. So if I want this first expected value right here, I need to take, so if I'm looking at 53, what is the expected low anger heart disease value? I want to take 3,110 times 190 and divide by 8474. You see how this would be pretty tedious to do by hand, because that's just one of them. And that's not even starting to get the chi-squared values. Quite a bit of math that the calculator does for us. So whatever that number is, we're about to see whenever we pull up the expected matrix. I just got 69.73 when I did that. So let's see if we get the same thing on the calculator. I press var, exp matrix, enter. Look at that, we got the same exact first number, 69.73. So if you're curious, that's how you do it, by hand. For that low anger heart disease number, you take those marginals, multiply, divide by the grand total, and you get them. But if I were you, I would let the calculator do all the work and move on. Look at that, 14.2. It barely checked out. These need to be bigger than 5. Having trouble reading my writing here. Hopefully these are right. I think you get the idea though. See y'all in class.